Hello, my lovelies. It's Susanna, and today I want to show you how to find the limits of these three functions. Let's start with problem number 1. We want to find the limit as x approaches infinity of this function here. And at the beginning, I would always check what really happens with your function as x approaches infinity. Because maybe it is not that bad and we can find the limit immediately. So let's see what happens. Let's start here at the beginning. We only have a 7 here. And as x gets bigger and bigger and bigger, what happens with the 7 here? Nothing. It doesn't change at all. There is no x in here that could change something. So the 7 will approach the 7. Nothing changes here. There is no x in here. Then we have the minus. Then we have the second part. Now we have an x in here. That will change. We said x approaches infinity, so our little x down here will approach infinity. And what happens to this fraction in total then? We have 1 over something that approaches infinity. This fraction then always approaches 0 because we have something here in the numerator that doesn't change at all. This will always stay a 1, and the denominator will get bigger and bigger and bigger and bigger. So 1 over a huge number will approach 0 eventually. So every time you have just a number in the numerator and something that approaches infinity in the denominator, your fraction will approach 0 in total, which means here our fraction will approach 0. Okay, what about the second parentheses? Here, there is no x in here, which means nothing can change here. The 3 will approach 3. And here in this fraction, down here, we have a little x. So our x still approaches infinity, which means our little x here will approach infinity. And this time, we have this plus 1 here. What does this mean for this denominator down here if we have something that approaches infinity plus 1? Well, the plus 1 is not strong enough to change infinity, so infinity plus 1 will still approach infinity in total. So our denominator down here approaches infinity. And what about this fraction then in total? So we have 2 over infinity. That's the same case we had here. We have a constant number divided by infinity. This fraction will approach 0 again. So here, this entire fraction approaches 0. Let's collect everything we've just found out for our limit. Here we had 7 as a limit minus, and here our limit was 0. Then we multiply this by, here we have the 3 plus, and this limit here was 0. So in total, 7 minus 0 is just 7. 3 plus 0 is just 3. So we have 7 times 3, which is 21. And this is the limit of this function here. So always just take a look at what happens as x approaches infinity, and maybe you will have no issues. You can just do all of your calculations and get your limit in the end. Let's see what happens with problem number 2. We want to find the limit as x approaches infinity of this function here. So at the beginning, we just check what happens as x approaches infinity. We have an x down here which will approach infinity. Then we have a minus here, and here is another x, so this small x down here itself will approach infinity. But what does this mean for this fraction then, where we have 1 over infinity then? Well, we had this case before. This will approach 0 in total. So here for this fraction, this will approach 0. What does this mean then for the entire denominator down here? In total, we have infinity minus 0. This will approach infinity because minus 0 doesn't change anything here for this infinity. So in total, for this denominator, this will approach infinity. But don't forget that we have this big fraction here. We have 1 over infinity. But 1 over infinity, we know now that this will approach 0. So in total, the limit of this function here will be 0 because we have 1 over infinity. Okay, let's take a look at the last problem here. We want to find the limit as x approaches infinity of this function here. At the beginning, let's see what happens as x approaches infinity. We have an x in here, so this x will approach infinity. And then we square this x. So we have something that approaches infinity and we square it. So it gets even bigger, which means it still approaches infinity. And then we also multiplied by 3. So something that is super big and we just multiplied by 3, it will stay big. So this entire thing will still approach infinity. And then we have the minus 5. The minus 5 doesn't change anything there. Infinity is so strong. So in total, for this numerator, this will approach infinity. Okay, what happens down here? Well, x will approach infinity. If we square x, it gets bigger and bigger and bigger. We'll still approach infinity. If we multiply it by 2, it will still get bigger and bigger and bigger, still approaches infinity. And then we add 4, it will even get a little bit bigger, still approaches infinity. So this entire denominator down here approaches infinity. What does this mean now for our big fraction? Up here we have infinity over, and down here we have infinity as well. And if you end up here in this case where you have infinity over infinity, you don't know what happens. Not at all. Your limit could be anything here. This here could be that our limit is infinity. Our limit could be 0, for example. Our limit could be 0.5. It could be 10. Our limit could be any number. So every time you get to infinity over infinity, you don't know at all what happens. So right now, we don't know anything. We just know that this way doesn't work to find the limit of our function right now. So we have to find a different way to find the limit of this specific function. It would be great if we could simplify this fraction a little bit. And one way to do it when you're working with limits is the following. Take a look at your numerator first and find your power with the highest exponent. So x to the power of 2 is our power with the highest exponent here. And then factor this out of this difference here. Let's see how we can do it. We want to factor out x to the power of 2. So what is left in these parentheses then? We have the minus here in between, and we want to factor out x to the power of 2 now. What is left here then? Well, from the first part, if we factor out this green part, only the 3 is left. And what happens here? We want to factor out x to the power of 2, but there is no x to the power of 2 in here at all. So this part is usually a little bit confusing at the beginning, but let's see how we did it here. How did we end up with the 3? The slow version is you take this entire part, so you take the 3x squared, and you divide it by the thing you want to factor out. So you divide it by x to the power of 2. And then you can cancel in this case, and only the 3 is left, what we had here. Okay, let's do the exact same thing now with this thing where there is no x squared in there, but let's see what happens. So we take this entire part, the 5, and we divide it by the part we want to factor out. So we divide it by x to the power of 2. And this time we can't simplify this here any further like we could do here, but that doesn't matter. This is our result then. So this fraction, 5 over x squared, is what is left here then. This is a little bit confusing at the beginning to get used to it, that we can factor things out that are not even there. Then we get a fraction in the end then. Okay, so this was the numerator. What about the denominator? Same thing. We try to find the power with the highest exponent, which is x to the power of 2, and we factor it out now. We factor x to the power of 2 out, and what is left in the parentheses then? This time we have a plus here in between. If we factor out the x squared here, only the 2 is left. And what about this part here? There is no x squared in here again. Well, we just learned that we then just take this number, take the 4, and divide it by the thing we want to factor out. So we divide it by x to the power of 2. This is usually the most confusing part at the beginning, but I hope you will get used to it, because now we wanted to simplify this fraction, and because we have x squared here and x squared here, we can just cancel it out. So we are left with the limit as x approaches infinity of this fraction now, where we have 3 minus this small fraction, and down here we have 2 plus this small fraction. And let's see what happens now as x approaches infinity. The 3 doesn't change. It will still approach 3. Here, this fraction, x approaches infinity. X squared approaches infinity. So for this fraction here, we have 5 over infinity, which will approach 0 in total. Okay, and down here, the 2 doesn't change. It will approach 2. And here, x approaches infinity. X squared approaches infinity. 4 over infinity will approach 0 then. So in total, for our limit, we have 3 minus 0. Down here we have 2 plus 0. The 0 is not important here. The 0 is not important here. We found our limit, 3 over 2, of this function here. By the way, the 3 over 2 are actually these numbers here. So we could have seen the limit from the beginning without doing all these things. That is always the case if you have the same power here and here, then you can just take a look at these numbers here in front. They create your limits. I hope it helped you. If you have any questions, please let me know in the comments. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care!